Welcome to our daily online series lessons. We inform you about Next Minds Academy Virtual Learning. We offer the following services. We offer subject discussions, for subject tutoring. We offer also a series of question discussions with answers in any of the topics that you wish. You can also visit us at our website, which is www.nextmindsacademy.com, and utilize some of the content that is there. We have notes, have questions, so feel free to go there and utilize them at no cost. You can book with us discussions in any of the subjects that you wish using any of our contacts. You can also access some of our recorded discussions on YouTube. Look for Mr. Academia. You'll be able to get some of our discussions there. So today we are discussing electricity questions. And in our discussions, we shall basically be explaining more about what the questions really want, and in answering them, we shall also be learning in the series of questions. So the first question is here, and it says, in a domestic wiring, bulbs are connected in parallel. So they want us basically to explain why bulbs are connected in parallel. So most times when doing connections in homes, bulbs are connected in parallel. Let's first look at what can happen. What if the bulbs are connected in series? So in series arrangement or in a series connection, it means bulbs will be connected in this way. So when bulbs are connected in series, as you can see in this case, so it means in case one of these bulbs goes off, especially if this, for example, if this goes off, this one goes off, it means that the two bulbs, this bulb 2 and bulb 3, they will lose their connection because all these bulbs utilize the same current. So if one of these bulbs goes off, it means that current will no longer be flowing and all the bulbs will go off. But when they are connected in parallel, for example, if they are connected in this way, they are connected in this parallel arrangement, like this. If one of the bulbs goes off, it does not affect the others. So let's say if this bulb here goes off, it does not affect these other two bulbs, bulb 2 and bulb 3 are not affected. For them, they will keep working if bulb 1 goes off. But if they are connected in series and this bulb goes off, then these two will also go off. So looking at the options that we are given, part A says to avoid short circuiting. This is not quite a better explanation. In order to use one switch for all the bulbs, even in series, we can use one switch so that they are all connected to the same fuse. This is not what we are looking for, so that a fault in one bulb does not affect the working of the bulb. So the correct answer for this question is this. So when bulbs are connected in parallel, a fault on one bulb does not affect the working of the other bulbs. Question 2, they are asking the watt is given by voltage over current. So we all know that a watt is a measure of power, what you can call electrical power. So electrical power is given by the formula power is equal to IV. Power is equal to IV, or what you can call VI. So and the units of power are the ones which we call watts. Or you can say watt or watts. So meaning that when we are looking for what electrical power is given us, in this case, since it is a measure of power, then our answer will be D, which is voltage This is supposed to be voltage multiplied by current. So this is what we call electrical power. Question 3, it says, it is here they've given us a circuit with two cells which are arranged in parallel. This kind of arrangement is what we call parallel. Each is of EMF 1.5 volts and each has an internal resistance of 2 ohms. So this one has an internal resistance of 2 ohms. Also this has an internal resistance of 2 ohms. Find the current flowing in the circuit. So to find the current flowing in this circuit, we shall use the formula which is represented here. I into R plus R. So in this formula here, this represents the EMF that is flowing in the circuit. Then I represents the current that we shall be looking for. R is the resistance that is due to the resistors. Then small r represents the internal resistance, which is by the cells or any other appliances in the circuit. So when cells are arranged in parallel, like in this case, the PDF, or what you can call the voltage that is used, is only the voltage of one cell. The voltage used is for only one cell. So meaning that in this kind of arrangement, the value of E that will be utilized will be for only one cell, which is 1.5 volts. So the resistor, which is the external resistor that we have, capital R, is 1 ohm. Then we can now find the internal resistance. Since these two cells are in parallel, then the resistance, the total internal resistance for these two is given by product over sum. Since there are two resistors in parallel, we can use product over sum. That will be 2 times 2 divided by 2 plus 2. We shall end up having 4 out of 4. And the answer is 1 ohm. So finally, we can go ahead and substitute what we have in the formula that we are supposed to use. So if we substitute in the formula, which is E equals I into R plus R. So E is 1.5 volts. So we shall put here 1.5 is equivalent to the current I that we are looking for, into R, which is 1, plus the internal resistance, which is also 1 ohm. So finally, I will be given by 1.5 divided by 2, and the answer is 0.75 amperes. We can write it as A. So meaning that the answer for this question is C, as you can see. The number 4 says, which one of the following equations does not represent the expression for power in terms of voltage and current? So to get the correct answer here, we have to derive each of the various formulae, different forms, or what you can call formulae, in which we can write power. So we all know that power is given by the formula IV. And we all know from Ohm's law, it tells us that V is equal to IR, the mathematical form of Ohm's law. So from here, if we substitute for V in this equation, we substitute for V in equation 1, in the equation of power, let me call it equation 1, and then this equation 2. So if I substitute 2 in 1, I will end up having power is given by I squared R. So this is another way in which we can write power. Then from this same equation here, from equation 2, if we make I the subject of the formula, we end up having I is equivalent to V out of R. So this is 4. So if we put equation 4 also, if we substitute 4 in 1, substitute 4 into equation 1, we shall end up having power as being equivalent to V squared out of R. So meaning that if we come back to what options we are given here, it means that this is a correct option because this is same as power is equal to IV. This option of I squared R is correct. Even the option of V squared out of R is correct. So the only wrong option here is this one. So this is a wrong expression of power. So number 5 is a high DC. A high voltage DC may be obtained from a low voltage DC by use of which of the following here. So a dynamo, of course we know a dynamo, for it converts mechanical energy. It converts mechanical energy into electrical energy. So this does not convert high voltage from a low voltage. Then a generator, generators also, they convert mechanical energy to electrical energy. So these ones, they are also not used for obtaining high voltage from low voltage. Then if we have to look at transformers for them, they are used to step up or to step down. They're used to step up or step down the voltage. So stepping up is converting low voltage to high voltage, and stepping down is converting high voltage to low voltage. So meaning that the answer for our question is D. Number 6, an electric motor is connected by a cable of 240 volts supply. The potential difference across the motor is 239 volts, and the current flowing is 5 amperes. The resistance of the cable is, okay, so they are saying the electric motor is connected to a cable of 240 volts. So if the cable is 240 volts, it means that the cable can only allow a voltage of 240 through it. So when the current flowing is 5 amperes, so meaning that we shall use the 240 and the 5 amperes since they are asking for the cable. So if we use the 240 and the 5, that will imply that we shall use Ohm's law, which says V is equal to IR, the equation form of Ohm's law. So if we are to calculate the resistance will be given by V out of I, and this will be 240 divided by 5. 240 divided by 5, I think the answer is 48. So meaning that the answer to this question is D, 48 ohms. Number 7, it asks us to calculate the cost of running 4 40 watts lamps, 4 of them, and 3 60-watt lamps for 5 hours if electric energy costs 10 shillings per kilowatt. So when measuring electricity or when calculating the cost of electricity, the units are measured in what we call kilowatt hours. So power must be in kilowatts and time must also be in hours to get the units. So meaning that we have to first calculate the number of units that are consumed by these 4 lamps and the number of units consumed by these 3 60-watt lamps, and then we add the 2, and then we multiply by the cost of each. So if we are to do that, for the 4 40 watts, to convert them to kilowatt hours, we shall first, since they are 4, so they consume 4 times 60. Then we have to divide that is watts, we divide by 1,000 to convert what we have to kilowatts, and then we multiply by the time, which is 5 hours. And on top of this, we add on the power consumed by these 3 60-watt lamps. So this will be 3 multiplied by 60. Then we divide by 1,000 to convert what we have to kilowatts, and then we multiply by 5 hours. So when we calculate this, let's calculate it on our calculator and see what we get. So if we have 4 times 60, times 5 divided by 1,000. That gives us 1.2. This gives 1.2 plus, on the other hand, we missed, this was supposed to be a 40. Maybe we can change it because we are not too late. So if we change that to 40, we shall have 4 times 40 multiplied by 5. This is supposed to be 800 divided by 1,000, which is 0.8. So this is 0.8. Yeah, so always pay attention not to mess up. Then on the other side, we have 3 times 60 times 5 divided by 1,000, which is 0.9. So the other side we have 0.9. So meaning that we have 0.8 plus 0.9. So if we add the two, 0.8 plus 0.9, I'll end up having the number of units as 1.7. So all these lamps, the 4 and these 3, they consume 1.7 units. So we can now calculate the cost by multiplying the number of units with the cost of each unit, which is 10. So meaning that the amount consumed, or the cost of electric energy for all the lamps, is 1.7 times 10. And the answer is 17 shillings. So the answer for this question is B. Okay, number 8, we have a current of 0.5 amperes flows through an electric lamp, which is connected to a battery of EMF 12 volts. What is the total resistance in the circuit? So a current of this is connected to a battery of EMF 12 volts. So here we directly use the equation V equals IR from Ohm's law, where the resistance R will be given by V divided by I. So if we do that, the resistance will be given by 12, which is the EMF, divided by the current, which is 0.5, and we end up having our answer as 24 ohms. Resistance is always measured in ohms, so meaning that the answer for this question is D. Number 9 requires us, we have two identical cells, each of EMF 2 volts. Oh, I think they made a mistake here. This is supposed to be 2.0 volts. Even this is supposed to be 2.0 volts. And negligible internal resistance are connected as shown in the figure above. Calculate the current through the resistor when switch S is closed. So when you have two cells in series, the EMF they supply will be given by, it is given by 2.0. We add up the individual EMF of each cell. So it is 2.0 plus 2.0, which is 4.0 volts. 4.0 volts. So since the cells have negligible internal resistance, so it means that the internal resistance of each of them is 0. So meaning that the total internal resistance is 0. So that means that in this circuit, we don't have any internal resistance. So we can go ahead and calculate the current using V equals IR. This is a very important equation, especially when we are dealing with electricity. So the V, we found it as 4.0 volts. This is equivalent to I, which we don't know, multiplied by the resistance. There is only one external resistor, so the resistance is 8.0. So the current will be given by 4 divided by 8, and this is a half, or which can also be written as 0.5 amperes. So meaning that the answer for this is 0.50 amperes. Then number 10, the power used in a resistor connected to a 12 volt source of EMF is, so here they've only given us 12 volts EMF, so we don't know what current is here. we don't know what resistance is here, and we all know that power, to calculate power, we either use the formula power is IV, or we use the formula power is given by, if you don't use IV, I will also use the formula V squared over R, or we use the formula I squared R. So meaning that if you don't have current and you don't have R, that makes it difficult for us to calculate the power. So in this question, it is inconclusive. Otherwise, stay tuned. You can check all our other lessons, and please don't forget to subscribe with us, Mr. Academia, and enjoy all our other lessons which are trending here. Thank you very much. I will meet for our next session of our electricity lessons.